Today we're working on this Kicker DXA 125 car amplifier, and it's going into protect mode and not outputting any audio as it does in protect mode. And I guess I can just go ahead and show that to you really fast. Over here is the light. I guess I can turn off my lamp so you can maybe see better. And the red protect LED is going on, which is not what you want in a car amplifier. This is just a baby 125 watt amp, but still would be nice to get going. Maybe hook up to some door speakers or something. So I was looking over the board, as you do with an amplifier that goes into protect mode, and I did see one thing that looks a little sketchy. Man, this camera doesn't get as close as my other one does. Should be okay. Right here looks to be a burned resistor, which is never a good sign. Maybe someone put in some reverse polarity and it burned up the circuit right here. That capacitor doesn't look too good either, but pretty sure that's just part of the audio section. I don't think that's causing our protect. I'm more leaning towards this resistor and maybe this transistor. We'll go ahead and look with the old microscope, and as you can see, I'm pretty sure that resistor is supposed to be yellow like the one next to it, and it's totally black and burned up. Let's go ahead and start with removing this resistor and just check it out. Well, check it out of circuit. So let's go ahead and do that. Third one over. 1, 2, 3. Go straight so they come out. Hopefully come out easier. Try these. Find out a little bit of light. Alright, got that. And there is our resistor out. We'll go ahead and measure that. And it does look like the board was a little bit torched. That resistor definitely got very hot. Alright, so I'm sure that's probably wrong, but let's go ahead and look at this under the microscope and see if we can work out what the bands, color bands, are supposed to be. Yeah, this resistor is completely toasted. I'm not even sure if I'm gonna be able to figure out what this was supposed to be. It looks like black, gold, yellow, black, black. Definitely black, gold. Black, black. Looks like black, gold, black, 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 maybe. Let's try to maybe clean it up a little bit. This probably won't help, but we do need to know the value of this. And then that looks like a white in the middle, gold, brown. I think that's what it is. Black, black, white, gold, brown. As good of a guess as we're gonna get. So let's pull out the bag of resistors, and we will try to find a 0.9 ohms. We'll do either 1 ohm or 0.9 ohms. Alright, I don't have a 0.9 or 1 ohm resistor. The lowest I have is a 10 ohm. So I'm just going to throw this in there and see what happens. Probably not a good idea, but we're going to do it anyway, because it's got to be better than this. I really doubt just replacing this one resistor is going to make our amp start working, but we're going to start here and just give it a try after putting this new resistor in. Looks like a little bit higher wattage resistor too, so that should be good. Hopefully the resistance isn't too far off, but it's a slightly higher resistance, so a 0.9 or a 1 ohm resistor should go there. But if we put in the 10, it should, this is my thinking, I could be totally wrong, but it should just get a little bit warmer, right? And if it's a higher wattage resistor, because it's bigger, it should be able to handle a little more heat. But if this resistor value controls like how long this transistor is on or off for, it could cause a problem. But I'm willing to risk it with this $10 amp, so we'll go ahead and see what happens. It's all about experimenting, right? Alright, I really doubt that's going to have made a difference in our protection status, but we are going to try just for fun. See if you can see if the light's going to go on. And we still have protect light. So that did not solve our issue, which I didn't really expect it to. Alright, I do have this thermal camera, so I'm going to go ahead and just look at the amp under the thermal camera just to see if anything jumps out. Can't hurt. That's just a reflection. Or is it? I don't know, it looks like that resistor right there is getting pretty hot. Yeah, that's warm. And that would be this resistor right here behind this transistor, which actually is pretty toasted looking. Right there. We'll go ahead and show you with the... So that is the resistor that is getting hot. We'll go ahead and pull that one as well. Alright, we're going to go ahead and pull that resistor, and we will try to see if this transistor is shorted while we're at it. Once we replace that resistor, we will pull out the oscilloscope and start trying to probe around and see if we're getting some waves that we should be. Probably should have started there, but I just wanted to replace that resistor first. Well, we got that guy out, and we should be able to see what he is supposed to be. Oh, great. You get real close if I can... Why does it get close if I get really close? But you won't zoom in close? What the heck is going on there? Oh, that is some BS. Man, I need a camera that will just zoom in really close from my stand. Alright, let's go ahead and try to figure out what this guy's supposed to be. Oh, and he's completely open, it looks like. How would you be getting warm if you're completely open? Oh no, you're not. 99 ohms. That's probably what it's supposed to be. What'd I say it was? Brown, black, brown, gold. Yeah, that's supposed to be 100 ohm. We'll go ahead and replace, just because we can. Brown, black, brown, gold. Bigger resistor though. That shouldn't hurt anything. Before we pop this guy in, let's just go ahead and check some things before. Let's check this. Let's just check between. Is that completely open? Now those transistors seem good. I'll just check the power supply transistors, which are charging caps. Alright, let's go ahead and throw this guy on there. Just probe around with the oscilloscope a little bit. I know this is not going to have made any difference, but we are going to try. Still red light. Turn on the scope and just kind of probe around a little bit. Alright, we do have an issue going on somewhere in this drive circuit, because when we probe and turn the amp on, it attempts to build a waveform, but it doesn't quite get there. So something is going on with something in this circuit. So we have to try to figure out what that is. And it's probably one of these transistors, this one, that one, or that one. Maybe one on this card. But I'm going to start by pulling this one, this one, this one, and this one, and testing them. And see how they test. And then if all those test good, then we'll start looking at the card maybe. And I'll just go ahead and show you, try to show you with another camera, try and hold it still. And so that's the waveform we're getting, which is not a very pretty waveform. And that's on both of the power supply transistors. So there's something definitely going on in the power supply drive section that we're going to try to figure out. And we're just going to pull all 4 of these transistors. I'm going to make sure these 2 are the same because I'm not really sure if they are or not. It's a 2N4403. This guy is a 2N4403. Okay, and these guys are the same, right? IRFZ46N, IRFZ46N. Oh! Wow, okay. Pretty sure I know what's going on. So this transistor is cooked. It's melted. So that is definitely what's going on. Let's see if I can show you more closely. Here, I'll put a light on it so hopefully you can see. That transistor has a hole in it. I guess I should have paid a little more attention. But it was just sticking straight up, so I didn't really see. But once I bent it down and looked, yeah, it doesn't have a short on it, but that's definitely not right. So we'll go ahead and pull these 2 transistors out, and then look at the waveform again after we pull those out. If it's stable, we'll go ahead and get a couple of replacement transistors. So, yeah, how close can I get? I think it's pretty dang close. Alright, so yeah, that's what we're going to do. Alright, let's go ahead and pull these guys. We'll go ahead and pull both of them. Guess that should have been the very first thing I checked, but I'm not super good at working on amps, but try to get it figured out. Just might take me a little longer than most people. Yeah, that guy is definitely melted. Should have noticed that right off the bat. Oh well, at least we got it figured out. Alright, let's go ahead and see what this thing is doing now without a melted transistor in there. And that is a pretty good wave, I'd say, on both transistor spots. So we will go ahead and wait for some replacements. I do not believe I have this model of transistor on me. No, I do not. At least there only needs to be 2 of them, so that's good. We'll go ahead and order some of those, and I'll get back to you when we're putting them in. Oh, just one more thing before we end right here, before we get to putting the new ones in. I still haven't got them yet, but I figured we could go ahead and do a little test of these just for fun, so we'll go ahead and do that. And oof, just testing as a resistor, huh? Oh, okay, I think you. Yep, okay, so they're both bad because this is the melted one. And I'm sure it's gonna not be good. Diode. Yep, okay. Just wanted to throw that in there just for fun. So, alright, we'll be back with the new ones once we get them. So, yep. Alright, so we're back with the Kicker amp. And we have some replacement transistors, and I think they'll work a little bit better than these old ones with the hole in them. These transistors are not the exact same. This amp had IRF 46Ns, and I'm going to put in IRF Z44Ns, which are slightly different, but on the data sheets they look very similar, so I think these will work. These were a little easier to find than the 46Ns, so we're gonna try and put these in, and if it doesn't work, oh well. I think it probably will, but if it doesn't, this is just a $10 amp, so kind of fun to just experiment on. It makes our life a little bit easier now. It is kind of frustrating there's no pad on the top here, because it is kind of nice to be able to tack in the transistor from the top and then flip the board over and solder it all the way. But we should be alright. Maybe do something like this to hold the transistors in while we tack them in place. Go ahead and just try to make sure we don't have any ridges. Which it doesn't look like we do. And we can bend those up when we need to, but let's just go ahead and do a little test real quick and see if we're working. Alright, let's go ahead and see what's going to happen. Got a nice wave. We have a green light. See green light. So she's turning on, and we have good waves on each one of our transistors. Let's check the so we'll hook up our speaker while we're at it. Dirty old blown test speaker works to let us know if we have sound or not. Go ahead and put a song on, and we'll turn it right down, and then we'll go ahead and turn it back on and see if we have sound coming out of the speaker. We should probably go ahead and make sure these are turned down, which I believe I turned them down before I hooked everything up the first time, so it should be alright. And let's go ahead and check it out. We have a green light, and we do have music coming out of the speaker. Yeah, so heck yeah, I don't want to play it too long because they don't like when you play copyrighted music apparently, so we mess with these inputs just a little bit to make sure that they are working all right. All right, it looks like everything's working on here. Nothing's getting hot. Let's see if this cap is getting hot. I would say let's change this cap, but it has like glue all over it, and I honestly don't think it's worth it trying to dig that cap out just to change it, because I don't think it will make a difference. It's just a audio filter cap, so I think we can go ahead and put this thing back together. So let's go ahead and start to do that. Alright, we'll go ahead and do one more final test, which we should be good. Give it some power. And we have green light. We are playing. Playing some funky rhymes. we should probably turn up the current a little bit. We'll turn it up to 3 amps. And let's do 13 volts. And it's working. Seems to be working pretty good too. Yeah, working pretty good for a little 125. Good for a couple of speakers, a couple of door speakers, or a couple 6x9s. Not really too good for an amp, or not really too good for a subwoofer or anything. But it'll work great for a couple speakers, which I'm sure that's what this was designed for anyway. So. Yeah, definitely working. So I think we can call that a win. We'll go ahead and turn off the power supply. Can unhook this stuff again. Go ahead and pop this guy back on. Again. Alright, so couple bad transistors, one with a hole in it, which we honestly should have noticed right off the bat, but that's what you get for not paying attention to stuff. We took out the IRF 4/6 ends and put in IRF Z for 4 ends, which seemed to work just fine. So yeah, got this amp working. I might throw it in my car for my speakers, or I don't know. I'm just glad to have gotten it working, and hopefully this video helps someone. Yeah, well, thanks for watching, guys. Hope you enjoyed it. Go ahead and leave a like, and I wouldn't mind a subscribe too. So cool. Well, thanks, guys. Well, till the next one. Take care.